So today in this video, we're going to be covering chapter 4.2, which is transformations of the quadratic function f of x equals x squared. I made a whole video for this. It was like 15 minutes long or something like that, and there was no audio. And so we're dealing with that. So let's just get right into it. So there are a few things to know when we're thinking about the transformations. Also, for the record, the first 4 questions in our book, not in our book, 4.1, 4.2, you don't need to answer. If it has an x in the exponent, then you don't need to answer that. It's a mistake on the book's part, and our instructor is going to change things up. I don't know if this is applicable to you now. Just make sure that there's, like if you're in the future, just make sure that there's no x in your exponent. You could have something like x squared, but as long as the x is not the exponent, then it's totally fine. There are a few things to take note of, and that is going to be stretches, compression, vertical, and horizontal shifts. So what we are going to do is there's a, so the book calls it standard form. I call it vertex form. Standard form. But I'm going to compromise and call it standard vertex form. But if it's referring to standard form, it's talking about vertex form. I'm not sure why they call it this. Standard form typically in the rest of math is the ax squared plus bx plus c. In this case, it's not going to be that. In this case, it's going to be the f of x is equal to ax minus h squared plus k. And this is really useful because this a is going to tell us about whether it shifts up or down. This x, the h and the k are going to be your vertex. So k is the y point of the vertex, and h is the x point. Now keep in mind when you're doing the cx, the h, the sign is going to be flipped. So if you had something like x minus 1, it would look like positive 1 comma whatever your y value is. And then so those are the main transformations. Also, if it is negative a, or just negative 1, or just negative times our x, that means that it's going to reflect over the x-axis. So let's get into some examples. We have, if the function f of x equals x squared is compressed by a factor of 5, what happens to the point 0, 0, and 1, comma 1? Now, if you remember, this is still applicable. When we were talking about lines, and in Lumen it was talking about the same type of thing, we know that the stretch factor and the compression factor are only affect the y value, and the y value is multiplied by that factor. So in this case, we'll do 0 times 5, and that will give us 0, comma 0. Our x value will stay the same, and then 1, comma 5, because 1 times 5 is 5. This one says the function f of x equals x squared was stretched or compressed. The point 0, 0 stays the same, but 1, comma 1 was moved to 1, comma 1 over 7. We know that if our x value is 1, on our parent graph, it's going to be 1 also, because we start at 0, then go up 1 over 1, and then sort of like go from there. However, if it is 1, comma 1/7, we multiplied this 1 by 1/7. So the answer will be it was compressed by a factor of 1/7, or by a factor of 7. It's not going to be the stretched one. It's going to be compressed. Sometimes they play word games with you. X squared is reflected across the x-axis. What is the equation of the transformed function? It's going to be, also don't forget your f of x equals part. I think Lumen will get angry if you miss that. So negative x squared is going to be your answer. That will reflect it. The function f of x squared was reflected across the y-axis. The point negative 6, comma 36 transforms into what point? Now, if you remember, it's going to be like negative 1 for a. So we're basically just flipping the sign of the y. So we have negative 6, comma negative 36. And then negative 1, comma negative 1. The function f of x is transformed by shifting the graph to the left by 6 units and down by 2 units. So there's no stretches. So we have our f of x is equal to x, and then we're going to the left by 6 units, which means that we're minusing by 6. However, it's going to be x minus -6, which turns into x plus 6, because the inside is always opposite. And then squared, and then minus 2, because we're going down 2 units. That would be our equation. F of x equals x squared is transformed by compressing the graph by a factor of 7. So we know that we're going to have, since the word is compressed, we'll have 1/7 times x, and then the graph is shifted to the left by 5. So we'll do minus -5 or plus 5 to the squared, and then up by 2 units, so plus 2. That would be the standard form, technically vertex form. I'm not sure why they're using standard form for this, of our equation. Determine whose graph has a vertex at -1, -3, and who passes through the point 472. And so we know that a graph, our vertex is going to be the highest or the lowest point. If we're at -1, -3, our graph will look something like this. And it passes through the point 472. So 1, 2, 3, 4, all the way up to 72. Now we want to find the function of that. Now, it looks tricky. We can't do this graphically. We have to do this algebraically. But lucky for us, we have all the components that we need. So we know our vertex. So in our vertex form, we have f of x equals a. We don't know our stretch factor. X, and then plus 1, since this is -1, squared minus 3. And so now all we need to do is find a. And we actually have another point. We have 472. And this is our x value, and this is our y value. So we can do 72 is equal to a times 4 plus 1 squared minus 3. And this will turn into 25a minus 3 equals 72. We're going to add 3 to both sides, and that will give us 75 equals 25a. Divide both sides by 25 to get a alone, and you'll get 3. A equals positive 3. And that is going to be our stretch factor. So we can rewrite our equation as f of x is equal to 3 times x plus 1 squared minus 3. And that would be your answer. Determine the function whose graph has a vertex at 3, -4, and that passes through the point 1, -16 over 5. Now, this one's scary just because it has a fraction, but it's actually it's going to be the same process. I will note that around this point, I'm not sure what the number of the problem is. There is one that has not been fixed yet where every now and then there are mistakes in Lumen where if you come across it and it says that you're wrong, even though you're pretty sure you're right, try again, obviously. But sometimes the system is just wrong. And I think it's one of the fraction ones. Anyway, so we'll just continue. We have a times x minus 3, because we're flipping the sign, squared minus 4. And then we'll do -16 over 5 is equal to a times 1 minus 3 squared minus 4. 1 minus 3 is 2. -2 squared is 4. So we have 4a minus 4 is equal to -16 over 5. We're going to add 4 to both sides. We need to have a common denominator between the two. So we have 4a is equal to, we're going to times this by 5 over 5. So we get -16 over 5 plus 20 over 5. 20 over 5. And this is going to turn into 4a is equal to 4 over 5. We can divide both sides by 4. And that will give us a is equal to 4 over 5 multiplied by the reciprocal, so multiplied by 1/4. And then these 4's will cross out, leaving you with a is equal to 1/5. So now we can come back up and substitute that into our problem. We'll have f of x is equal to 1/5 times x minus 3 squared minus 4. That would be your answer. If you have any questions, please let me know.